Hello, how's it going? In this video, I'm going to talk about three updates or three optimizations that I made recently. Now, as always, OBS is going to reduce this frame rate a little bit, but here we are at the moment. We're no longer falling through the blocks. The first update is pretty simple, the optimization. When the character goes into an idle state, that isn't really an animation. It's like a placeholder. So I configured the idle animation to not continue upon exit. And what that means is that when we go into the idle animation, we go into the idle pose, but then the animation component is removed from the database. This reduces the processing. I found that processing the skeletal animations was a significant load. I also previously had an animation system independent of a skeletal system, but now I've merged them together because we only need to recalculate the transformation matrices if an animation has occurred. If no animation has occurred, then the stuff that was previously calculated is perfectly fine. The real benefit here is it's not just the character's animation which is being removed from the table upon idling, it's all of these monsters as well. So whenever any of these monsters in the world stops moving, their animation is no longer being calculated, and that is giving significant speed ups. A further optimization that I could look into is only animating objects which are within the view frustum of the camera. They would still move around, they just wouldn't animate if we can't see them. And these next two optimizations are a little more code-based. Let me talk about collisions. So I finally implemented some sort of spatial hashing, and this isn't even full spatial hashing, this is just spatial hashing currently based on the x-axis. Upon adding a block, we just take note of how this relates to the world. So we update our minimum and max points of the world so that we have a single large box which encompasses everything. And then upon adding all of the blocks, we then work out which blocks are in which little virtual X interval. What I'm getting at, okay, is that for each little interval with a width of 5 along the world, there's a vector of unsigned integers which corresponds to the indices of all the boxes which are overlapping with that. So that then when we move, all we do is we work out which virtual box we are in, and then we look at only the boxes in that interval and search against those. The third and final optimization is in the component set. So the component set is using the binary search algorithm to find a given component. Binary search is speed log n, which is pretty good, pretty optimal in fact, but I can get that down to a constant speed by saving the last search request and the last result of that search. So let's say, for instance, you want to check if our set contains a given entity. Well, first up, does that entity match with the last search result? If it does, then we can simply return the result of the last search result. If it doesn't, then yeah, do a new search, and by the way, update your last search result. There we go. It's probably not great. I do have an issue with some of the messaging, the way my objects are passing messages to each other. So I'm going to rebuild the messaging system, rework it a little bit. There's a little bit more for me to do. I know that sort of tapered out a little bit at the end because I sort of started thinking to myself as I was presenting, but those are the optimizations that I've done. So all the best, and I will see you again soon. Bye.